Hello and welcome. File in, grab your seat. My name's Michael with AI4. We're just going to hang out for a couple minutes as people join, and then we'll get started. And in classic AI4 fashion, Diego, who's our speaker. Tell me, Diego, where did you grow up?
I grew up in Uruguay in South America.
Whoa, I've never been to Uruguay. What's Uruguay like?
Yeah, so it's way south. So think end of Brazil, and across the street from the beach, which is very highly missed now that I live in Seattle. So not having the ocean right next door, but it's a beautiful country, tons of beach, it's great.
That's awesome. That's awesome. Hey, everybody. Welcome. My name is Michael with AI4. We're just going to hang out for a couple more minutes to let people join. In the meantime, enjoy getting to know our speaker, Diego, a bit more. All right. So what was your favorite game, either board game or imaginary game growing up?
Oof. So I got pretty early into video games. So it was the first game that ever came out in a CD-ROM that I was really into, which was a Star Wars game. I remember playing that as kind of more of a teen than a actual like kid, and that was probably I played way too many hours. More traditional, the first StarCraft was big.
Nice.
I played a lot of that. And then sports, I've always liked playing sports a lot.
Nice. Which sports?
So I play rugby. So I've played rugby for almost 23 years now.
Wow. I played football actually in college, but I feel like rugby is like football, but with no pads. I mean, it seems like a crazy.
Yeah, it's kind of I would say it's more like soccer in the sense of continuity of the game. So, you play 40-minute halves nonstop, and there's tackling involved and no pads, but it's kind of different kinds of impact than there is. It's a very fun sport. I highly enjoyed it. And still do today. Play it out here in Washington. Well, during this pandemic, there's no sports, but when there is sports, I get to still play it.
That's awesome. That's awesome. Hey, everybody. I'm Michael with AI4. We're going to hang out for one more minute before we get started to let others join. In the meantime, we're getting to know our speaker, Diego. And then I'll ask you one more question, which may not be relevant may not be a childhood question, but how did you get into, the whole AI machine learning world? Like what was your original motivation and inspiration?
Yeah. So it actually started even before, kind of like, machine learning and AI were really general, kind of like top of mind. So super early on in my career, actually, first year in college, I had an internship at a consulting company. And during that, this consulting company did this new area called business intelligence, or BI, and which I had no idea what it was about. And it was, kind of fascinating because I went in with the salesperson for this consulting company, and his first thing he did at the sales meeting was, let me tell you something about your business that you don't know, which I thought was really bold and kind of like forward, and to go to somebody and say, let me tell you about your business. But what they did is, and for those of you who've been in the data space for a while, he grabbed some data, built out a crystal report just dating me on how long ago this was. Maybe some folks in the audience remember crystal reports, and kind of showed groupings and aggregations of the data on kind of like what was happening with the sales of this particular company. They sold some manufacturing widgets. And I was so fascinated by the fact that you could use data to interpret business stories, to actually explain what was going on and make decisions, that I fell in love. That was after my first year in college. I switched from mechanical engineering to a specific data analytics track. So I changed my entire career based on that moment. And I've been working in the data analytics space ever since. So did my undergrad in that, did my grad school in that, went and worked on Wall Street in data analytics, then worked at Microsoft in data analytics. Like it was kind of that pivotal moment where I was like, this is what I want to do for the rest of my life.
Wow, that's awesome. What was the person's name who gave that recommendation? Just first name.
Well, so this was a company in Uruguay called Quantum, and the person, my kind of manager at that point, his name was Guillermo.
Guillermo. We can thank Guillermo for the existence of Diego's interest in this whole webinar today. All right, without any further ado, welcome everybody. My name is Michael Weiss with AI4. You may know us through our events, tutorials, webinars, blog posts, Slack community, all focused on how AI is impacting the industry. I am very excited today because we have an amazing speaker, Diego. I can think of few people better equipped to help us understand operationalizing ML within an enterprise setting. And so a couple housekeeping notes. You'll notice on your Zoom toolbar the Q&A button. And so anytime throughout the next 45 minutes or so of this presentation that you have a question, please go ahead and submit it through the Q&A. And then at the end, we've made time so Diego can address those. And then, yeah, that's pretty much all I have for you. And so now I'm going to kick it over to Diego, who will give us a more formal introduction. And then I will be here, Diego, if you need anything. And I'll help with the next slide as well once we get to the poll. Have fun.
Awesome. Thanks so much, Michael. I'm really excited. Thanks, everybody, for spending some time with me today. I'm excited to chat about this subject. Obviously, it's near and dear to my heart. So really quickly, a little background on myself. I'm the CEO and founder of a company called Algorithmia. I've been in the data analytics and building out enterprise analytics stacks pretty much my entire career. Spent a lot of time at Microsoft building out some products that you might have heard of before, like Excel and Power Pivot, SQL Server, Power BI. So a lot of passion for the space, and I obviously really enjoy it. So just to kind of get this started, we always like to do a little bit of an understanding of where people are in their journey, kind of get a little bit of an understanding of where folks are coming from and how they're approaching this. So today's talk, to give a little bit of to give a background. So there's a lot of talks around kind of like the technical aspects of how do you build out machine learning models and how do you actually productionize and use different frameworks. Today I want to elevate that conversation a little bit to think about process, to think about KPIs and measurements, but really the most important thing that I want to focus on today is how do we get to success? So success in machine learning really comes down to, like, honestly, any analytics workflow is how do we actually answer a business question? How do we affect our P&L? How do we actually use this great technological tool and understanding of our data to make better decisions, to make better predictions, to really affect how our business is actually, moving forward. And so the framing for today's chat is really going to be around things to consider as your organization moves from an exploratory, how can we actually use machine learning, to affect our business, to how do we actually really productionize this entire process? How do we actually scale it? And how do we make sure that this is a continuous learning and ROI for organizations? So that's kind of what we'll be chatting about today around this. This is the best estimate on the poll. I'll give it a couple, another 30 seconds for those of you who are still joining to answer this. And then we'll kind of talk about what's happening in the industry and go from there. Great. So one of the things that we've been noticing, so every year Algorithmia does a pretty expansive survey called the State of ML. You can actually go and look at the report, download it for free, whatever you want, at algorithmia.com/stateofml. And so one of the things that we really ask about is, I think nobody has an argument that machine learning is going to be one of the most transformational technologies, if not already is, to organizations, in our lifetime. And so how organizations are approaching it becomes really important. So what we did is we went and asked, kind of year over year, what are the challenges of getting machine learning into production? Where are what is the time being spent? So, 25% said that, a lot of the time the data scientists actually spend on deployment versus the actual model production, which is really high. 55% of companies are looking at machine learning, but they are not have not deployed a model yet, and they're looking at how to do that. And again, this overarching theme that you're going to hear about today is if a model does not reach production, there is no value, right? ROI in the world of machine learning only happens once a model has actually been able to be integrated into an application and actually start running and affecting that business. And so it's really important to think about the final goal. It's not just about the accuracy or the better data. I mean, these are all important, but the overarching theme needs to be, how are we going to affect our business? How is it going to drive, either increases in revenue, decreases in operational cost, efficiencies around how we do our processes? This is really the important focus around machine learning. And so having that foresight and that kind of like future look into like, hey, how are we going to actually deliver this becomes extremely important for organizations who are going to be successful at this. So let's talk a little bit about the machine learning lifecycle, and more importantly, how it differs maybe from other things that we've seen before. So the one thing that is really interesting from, if we think about data scientists as kind of software engineers to a certain degree, they are the fastest moving, software engineers that we've ever seen in industry. And the reason why I say that is the iterative process. It is a process of constant iteration where data changes, model changes, conditions change, and those become extremely important. So you have to have a process in this life cycle that actually allows for that iteration. And so we think about kind of like two big areas to that. One, which is, how do we actually develop these models? The training, the data prep, the kind of like experimentation. How do we manage that? How do you actually look at that perspective and scale that out? And then you move over to the world of production, operations, and deployment, which is, how do we actually manage these things in production? And one of the interesting aspects of this that I think is particularly relevant is, while the data analytics stack, and I talked a little bit about BI analytics stack, is, we're pretty self-contained in the sense that, you prepare data, you had your data warehouses, you would create your OLAP cubes and measures, and then you would deploy your dashboards. The end result was in a dashboard, and so it could be fully contained. Now, in the world of machine learning, the final result goes into an application. So we have a whole new set of requirements now to get an application into production. There's a whole DevOps software development lifecycle that exists. So a very important part of thinking about machine learning at scale and how to get there is to how do we merge the world of that machine learning lifecycle into the traditional software development lifecycle that exists as an organization. And there's a lot of overlap from a DevOps perspective, but there's also a lot of unique things. And so those are some of the things I'm going to talk about and how to measure those risks and KPIs today. So while in the world of model development, you're going to be doing iteration, changing of data, experimentation, hyperparameter optimization, experiment tracking. This is kind of the management side. You also have to have governance and security around that. Are you accessing the right data? Are you training models with the data you're supposed to be? Do you have controls around audit? Do you have controls around explainability and observability of the training part of that life cycle? And then once you've actually gotten to a result and a model that can go into an application, then you start thinking, okay, how am I going to connect to the data services that are providing that data for inference? How am I going to be able to register those models into a controllable, observable, manageable framework? And then how do I actually scale that? How do I make sure that we have the right backups, the right uptimes, the right SLAs, the right monitoring, the right reporting, the right infrastructure management? Who can access those models? How do we have the proper InfoSec compliance so that these models can actually go into production using the library? Is the TensorFlow library you're using approved by your security team? Do you have the proper regulatory compliance set up so that if one day a regulator comes in for your life sciences workflows or your financial services workflows, you can actually provide them full audit controls backwards around that? And remember that what connects to these machine learning models is applications. So these things will actually be exposed in applications that have their own life cycle, they have their own refresh cycle, and they have their own conditions around reporting and stuff like that. So today we're going to talk about a little bit about kind of like what the measures and KPIs we can do from a leverage and risk perspective. So, a really important part is shortening the time to market. So automating deployment of models shortens that time of market that it takes from productionizing a model from months to hours. So we've seen a lot of use cases, especially in complex organizations, where it can take anywhere between 9 and 12 months to get a model in production. Even a month is too long to move a model into production. And if you think about what is the result of that model, so that optimization, every day that is not in production is a day that you're not getting the advantages of that. So if you're thinking about financial services and you have a risk model, every day that your model is not in production, your risk profile is elevated. You are not getting advantage of that. If you have a upsell kind of marketing e-commerce type of machine learning model, every day you don't have that is the way that you're not enjoying that ROI as an organization. You want to reduce your IT ops overhead. So again, this is another thing that's going into that IT workflow that exists as an organization. And the ops overhead can be really, really expensive if it's not managed. We want to provide data scientists and machine learning engineers with the proper speed of iteration and model optimization. As data changes, as world conditions change, these models need to be updated extremely quickly. So providing that highway, and if we think back to the principles of DevOps, which was how do we actually create a fast way of iteration and recreation? We want to add that exact same idea back into the world of machine learning. Model reusability, and although model reusability across organizations is somewhat limited, inside organizations, we see a lot of potential for reusability. So data sources where you've built extractors for them, or you've being built features around, data sources where you've actually seen, hey, we already have a model for analyzing this type of documentation. Those are things that can be reused across your organization. But today, they have to be rebuilt in every single pocket because because there's no sharing capability, there's no organizational capability around that. Infrastructure and scalability and cost are another concern. So these are pretty compute hungry workflows, and so the cost can really skyrocket. So optimizing your infrastructure for runtime and inference, being able to scale across the proper hardware so that you can actually take advantage of cost controls is also extremely important. So, and then the risk, how do you actually measure those KPIs, measure value? Time to deployment, how many models in production do you have? So you can actually see kind of like a gain and growth in terms of every single time you're getting some efficiencies around it. New models deployed each month, API calls to those models. This is a great way of understanding what value is happening. And then when you're an organization, and especially an organization who's thinking about centralized data science and machine learning teams, how do you actually produce a way of showing the costs of these models, how the different parts of the organization are using them, and being able to distribute that, not only from a cost perspective, but also from an audit perspective of who's calling what, when, with what data. So let's talk a little bit about shortening the time to market. So what do we get in here? So automating deployment paths. So this is really about just getting an approved IT way to very quickly get deployments done. You want to see very quickly that impact of that model in production. And then you also want to be able to register and monitor in the reporting around that. So we think about the data scientist or the machine who's actually looking at the development, they're developing the new model. They want to provide this to the ML engineer who will actually put it into production. And this is where we start looking at the automation around deployment and operations. There's a DevOps person involved. There's an app owner involved. Why are they involved? Well, the app owner wants to make sure that there's uptime, that the actual application is running in the way that it's supposed to, that it's meeting the SLAs that they care about. The DevOps person is actually responsible for making sure this whole thing runs. So, who's going to actually get at 2 a.m. a pager that something went wrong? It's going to be a DevOps team. So they're involved in this process and actually pushing that forward. And at the end of the day, the business owner that owns the application is actually going to be the one who's the customer of this. So today we're seeing an average time to deploy of over 31 days. This is extremely slow. And gains on this can be done by automating the path and actually seeing what it takes from a model has been actually declared, kind of developed and approved, to getting into the hands of that application and customer becomes extremely important. So we've talked a little bit about an example here, which is, with a top 4 consulting firm. So the challenge this customer had was that they were building ML models for fraud detection and compliance, but getting a model into production because of the nature of what data they were working with and the InfoSec requirements was taking them almost 18 months. And so during this time, criminal patterns, behaviors adapt. This is an ever evolving, the data changes, the use cases change, ever evolving. So by the time a model could actually get into production to start producing results at an organization, you were already in a position where they were already, essentially expired or not really relevant anymore. So what we were able to provide them with this automation was a workflow for machine learning that allowed them to get very, very quickly from experimentation to full on in production. We, you enabled a modular pipeline for model reuse. So being able to say, have different extractors, pre-processing functions, post-processing functions, and combining those through pipelines and deploying those allowed for very, very quick editing, actually subbing out different parts of models. One thing to point out here, and as you all probably know, models don't live in isolation, right? They're part of pipelines. They get actually ensembled together in some cases, but they also live as part of pre-processing and post-processing functions. And so being able to swap out modules of that to improve different pipelines is extremely important. And at the end of the day, the result is what matters, right? Deployed over 100 models with 10 different open source frameworks and more than 75 libraries attached to that in under 5 months. That's the measurement that we can go look at and say, this is the business impact we're having. We went from a model or two taking us almost over a year to be able to get into production to a speed of iteration that now actually allows delivering higher quality tooling to their organization and to their customers to, at the end of the day, catch these criminal patterns around fraud detection and compliance. So reducing IT ops overhead, and this is really important because, in a lot of cases, and we have this conversation all the time, while there's a thought that you could just grab a model, put a container around it, deploy it in an API, APIs and containers and models in production will be run by IT operations, and they actually have a cost associated with them to be able to do that. They need to be able to provide security controls. They need to be able to provide compliance controls, and they need to provide, actually efficiency around how these models are running. So when we look at this diagram and kind of like, this is a generalized and high level overview of how model development will be pulling in from training data, which is going to be provided by ETL providers, data warehouses, and DBAs inside an organization. There's going to be a number of tools that are going to be used. At the end, just like developers, data scientists have their preferred tools. There's certain libraries that are better and frameworks that are better for some things. There's certain ones that are better for other things. And so being able to actually develop those models and then in whatever tool they feel the most comfortable. Now, IT needs to be able to deal with whatever comes at them. So thinking generic, thinking self-service, thinking how model operations can take everything that exists today, but also all future things. These frameworks are really, really moving forward at an amazing pace in terms of how new frameworks are coming out, new libraries, et cetera. And so we want to start thinking about self-service. How do we allow the data scientists and model development teams to have a path to productionizing their models in an automated way that still provides IT with the approved operations around API design, security, governance, compliance. And again, the goal here is always to get that done with the least expense possible as an organization and as delivered to the customer applications as quickly as possible. And there's one definite truth, which is tomorrow you're going to have more models and productions that you had today. And tomorrow you're going to be dealing with more frameworks and different development tools than you have today. And so thinking how that's going to scale, how you're going to actually get to results becomes extremely important. And again, from Gartner, we actually pulled out that, next year, by 2021, we're going to have 2 times the new AI projects. So this is growing at an impressive rate. And so thinking about how we're actually going to get our hands around IT overhead becomes extremely important. So a good example of this is, an insurance group that we work with, they had some challenges in experimenting with computer vision and ML models for rapid prototyping. And every single time they wanted to get one of those models in production or start running those prototypes, they would have to build infrastructure to be able to do it. The actual operational cost became completely impossible for them to manage, because it would mean building out an entire DevOps teams just to manage this, which was really not a reality. So with a solution that actually comes in and provides them that fast path, how many models they have in production, where the call and errors, how hardware utilization is going, they were able to actually create a very quick path from experimentation to production without increasing their IT overhead. So I talked a little bit about the model reusability, and I like showing kind of a graphic around this, because how this makes around rapid iteration. So pipelines change. So if I look at an example, we have some data around 80% of enterprises will face production delays due to lack of collaboration and IT process maturity. If we think about a pipeline as a process, as each one of these components, and have different frameworks, different languages, different refresh cycles, different data sources, being able to actually pop out modules and pop in a new module in a pipeline around that becomes really important. So how do we think about iteration? How do we think about freedom of use, freedom of choice? And how do you do pipelining so that you can now actually understand, hey, if we just got a new translator, a new vectorizer, could we just pop that into our current pipeline without having major effects? And there's no farther way to look at than like kind of the improvements. So we're particularly excited about for those familiar with BERT models and what they're doing in the NLP space. And one of the interesting things is, although from an accuracy perspective on runtime, they are fantastic and they're providing new ways of doing it, they now bring some performance challenges, much larger models, inference time seems to be like slower in certain cases. And so being able to actually pop out a specific module, put in a new, better module for accuracy, and then start testing around that. Hey, are we missing our SLAs? Are we actually running in the same efficient way? It becomes extremely important. So that rapid iteration and model operation is how you actually get to scale. And then again, how do you expose all of this? This is APIs integrated into any sort of consuming applications, which can be runtime applications all the way to visualization, or to your CRM system to understand, hey, what are the signals in my customer behaviors that allow me to actually deploy models that in effect, how I serve those customers. So in this case, I have a good use case in financial services. They wanted to integrate user data and apply models in real time, provide advice on how to pay down personal debt. We were able to integrate real-time and batch data from financial services firms to run those models and generate those recommendations. Again, this was extremely important to get to market as quickly as possible with all the models that a really, really talented data science team was building. And so if you think about, this is an organization that understood the effect that the data science could have to their bottom line. And so being able to iterate, get new versions of the models extremely quickly into production, provide new models for different use cases at a high speed. This is actually how they would be able to affect the business. So that rapid iteration and model operation became key for their success. So I talked a little bit about model reusability. So when we look at what are the top use cases that organizations are applying to how they, what they want to do. They want to reduce company costs for using ML. They want to automate processes inside the organization, and they want to improve customer experience. And so if you start digging a little bit deeper into that, the customer experience, there's a lot of common data sources, right? You're going to have your data, your customer data systems. And so building extractors, building, kind of how that data is treated, what signals can be getting out of the data, there's a good chance, a high likelihood chance that you're going to be able to reuse some of these models. So being able to provide a way for models to be reusable, how to actually allow them to be kind of future-proof in certain case, then more importantly, how do you do that model maintenance when you potentially have hundreds of applications across your organization relying on these models? So how do you manage who's calling these models? Do they know there's a new version? How did you apply that new version? Can they still run on the previous version? Do they understand where those models are coming from, how they were trained, and how they were built? So thinking about your machine learning models and your as assets to your organization that need to be cataloged, that need to be understood, that need to be kind of like referred to how they're building ROI becomes extremely important. And this is all part of that model reusability. Can I go and reuse those models in a different place and get ROI on those investments? So another example of this, logistics consulting company that we work with, they needed to go, they were building applications and deploying it to many, many different customers, and their baseline models were the same. So being able to actually build out the model, deploy it to multiple customers, update those models, and then update it at multiple customers became super important. So this workflow of reusability and model deployment as a serving engine, the ability to actually change data connectors, slightly change data pipelines around it, but more importantly, being able to upgrade kind of models at scale, right? One to many became extremely important for that KPI in terms of success around model reusability. Then we talk about infrastructure and scalability. So the most common way today to host a model is to put it in a Docker container, put it in a large VM enough to fit the model, and put some load balancers on the outside of that will actually just create more VMs. So this is somewhere in that middle in terms of local maximum planning. In traditional cases of capacity planning, you would just build out the entire capacity of that model inference and pipelining, and it's extremely wasteful and expensive with some hard capacity limits. In the second, in the example I started out with, you can get some efficiency around building out, those VMs, but it actually is still quite inefficient from a compute perspective. When you actually look at a serverless way of actually deploying, or let's call it just-in-time computing, which I think is a better descriptor of it, you can actually massively, you have efficiency around only consuming the compute that you need, being able to scale extremely quickly around those limits, but also be able to reduce your footprint so that your organization is not having really jumping out IT costs from from these workflows. And so if we look at how much compute is being moved for AI to the cloud, the growth here is extremely expensive, and it will be absolutely the case that CFOs at organizations are going to be taking a really, really close look at how this is being spent. So you want to start thinking about the efficiency of your computational resources in AI so that they can actually match the ROI gains. Because if you actually see a model producing results for your organization, but the amount of compute, you're essentially taking away at any sort of arbitrage on advantages that you get with that. And so thinking about, hey, how am I going to actually compute this entire pipeline? How is it going to run? What is it going to cost around that? And being able to control those costs becomes extremely important. So how can you do that? Well, auditability, chargebacks, showbacks becomes a really important element of this. So how do I know who's calling what model? How do I know how much they're calling that model? How do I know how much computational resources that model is taking across that global take that I have on my organization? So I can see everybody who's actually calling these models, how much compute they're using, how much memory, and understand really efficiently, hey, this is what this is costing us. It also provides a really easy way of doing audit. And again, going back to what I started this conversation with, we care about ROI, right? The entire process of machine learning is just a tool to get an ROI on some sort of business process. So understanding what the advantage is, what that application is producing, how I'm understanding what the ROI is from that application, and being able to bring that back in the journey and understand the computational costs and infrastructure costs along the way is going to be really important for us to get really successful with what looks like, in this world of machine learning. So to kind of wrap this up and go back to, the measures and KPI, how do we leverage measure impact? We want to see shortening time to market. We want to see a reduction in IT ops overhead. We want to provide a path for rapid iteration and model optimization. We want to think model reusability. We want to understand our infrastructure scalability and cost. And KPIs to measure value is really how we can actually understand those things, which is how long is it taking us to deploy a model? Are we losing out on opportunity because of that? are we seeing a higher increase of models in production as time goes, which means our entire organization is becoming more efficient at this process. When we look at new models, from a deployment perspective, are we actually being able to iterate into production as quickly as our really talented data science team is, right? Because they are going to go at a lightning speed in terms of iteration and build out and understanding data sources. So can we match that from an organizational IT perspective? We want to understand who's calling these models and how much they're calling them, because that's how we can actually trace that back to the effect that they're having inside our organization. And finally, as I said, we want to be able to audit and understand what's going on in that organization so that we can actually measure all of these risks and KPIs around that. So quick plug on this in case anybody cares about it. Obviously we build a product that does a lot of these things that we just mentioned. Algorithmia Enterprise is a platform for model deployment. So connecting to data sources, loading, doing inferencing, cataloging, versions, validating models in production. We provide a layer for the model operations, managing costs, infrastructure usages, monitor operations, delivering models and services at a high velocity. And finally, all of this will not work unless there's really, really strict governance and security around rule-based controls on user, data, infrastructure, and models that are kind of cut a part of that package. So with that said, for those of you who want to understand a little bit more and a much more technical of a discussion, on June 9th, we have a webinar for building versus buying your machine learning operations platform. So it'll be a really great discussion around how you can invest in this. And if you're actually thinking about building it yourself versus buying it, some of the questions that you should be asking yourself. So that is all I have today, and I'd love to answer some of the questions that are coming up here. Thank you so much for hanging in there.
All right, yeah, you crushed it, Diego. Thank you. So we have a bunch of questions. We'll do our best to get to as many as we can in a reasonable time period. So I'll just go down the list here. So first up, what are the time spends on cleaning and building metadata on complex use cases?
Yeah, so that usually happens at the training side of things, and it's actually one of the most expensive tasks from a data science team. So preparing the data, it really depends on the organization. So some organizations have really invested over the last couple of, I would say, 5 to 10 years in terms of structuring their data warehouses, structuring their data sources, their data pipelines. And so they've done pretty well in terms of this. And obviously, when those data sources are well managed, metadata is associated with them, understanding access tends to be the biggest problem. Does your data science team have access to the right data sources where they spend a lot of time? So, that task could be very quick for organizations who have actually developed a pretty mature thesis around data management and data systems, ETL pipelines, or it could be really, really expensive and a lot of time taken in organizations who have not done that kind of investment up front.
Cool. Thank you, Diego. All right, here's one I like. In your rapid model development example for financial industry, have all the model developments been reviewed independently?
Right. So in our particular case, we have an approval workflow. So, usually what we see in financial services is there's a data science team that gets approved to use certain kind of data. They will iterate on the model, doing their normal experimentation around, hey, these are the data sources, these are the conditions, these are the features that we can use, these are the parameters. And once they get to a result that they are happy with, that usually moves to a compliance team, which will review what was used, how it was used before it gets approved for production. This is not a technology workflow. This is a human workflow for approval that is usually tied to some regulatory compliance needs. So every single bank that I've ever talked to has a pretty well-developed compliance team. They have really good workflows. They've been doing this for many, many years. And so this is really just about having your machine learning pipelines and data science workflows participate in those kind of like approval workflows.
Cool. Thank you, Diego. Here's another interesting one. What are your thoughts on use cases and applications that need edge deployment and cloud is not an option? Examples, right. Defense, robotics, et cetera.
Totally. So I think there's going to be a number. So edge is it's a multi-use term for different things. So one could think of edge as, hey, it's in a factory floor, right? It's in a manufacturing facility where there's technically a server room inside that. One could think of it as a mini private cloud. In those use cases, you can still deploy a platform like ours or any others that can provide kind of like API, like calls over an API. So you obviously need compute, you need network, you need storage to be able to enable those. In the world where you actually are thinking of edge as potentially, hey, I need this to run on a cell phone. I need this to run on a actual, like an autonomous vehicle where we cannot rely on a network connection to anything outside of the kind of perimeter of the device. You're going to have different conditions on how to get those models in production. But in terms of how do you actually test those, how do you actually do that? So one can actually take an example of how testing gets done from like how app developers for mobile phones test, multiple different target hardwares. And you're going to have to start thinking what that battery looks like in terms of being able to produce those workflows for those target environments. So to kind of sum up the answer to that, I think, cloud, on-prem, and then in certain cases, these kind of like manufacturing facilities with private servers are kind of all in the same world because there's a device can connect over, even a Raspberry Pi can connect over a network to do API calls and inference. And then there's another class of those which are like, hey, we cannot rely on any sort of computational power or networking that's outside of the device. And you have to think about those two use cases slightly differently.
Awesome. Thank you. Yeah, edge is the future. All right, here's a good one. So how do you decide the right tools for model building while the platform you mentioned is for containerization and model management?
Yeah. So I think, the right tool, I would say, my easy answer is use the right tool for the right, for the right use case. A lot of times that right use case can come from personnel. So you just hired data scientists who feels really, really comfortable in our studio using R with certain statistical libraries. They should be building their models in R. You have a team that has seen really impressive results in terms of how they're using like language models on TensorFlow and they're really comfortable with it. They should be working in TensorFlow. So the model building tools, very similar to how I would think, we've dealt with developers forever, right? Like it's very rare that you go to a developer and say, you're going to use this ID, you're going to use this language, and there's no other option. We really want to give flexibility for them to use whatever tool they feel comfortable with, because if what we're really working on is ROI and time to market, that's the fastest path, right? Let them use what they want, let them use what they know, and really focus on time to market. So they're making decisions around model tools, I would argue is really what is going to get you to a productionizable model faster than anything else. And that would be my focus.
Got it. Great. Thank you. Here's one. So around like sort of cost and scoping out the project of actually building out a robust ML operations pipeline. Let's say, you're an organization, you're not a bank and you don't have a super robust ML operations protocol built out yet. How do you think about costing that out? And then it's kind of sub question to that. What are some of the key either levers or internal people who need to get on board, or just like, how do you get momentum behind your MLOps program?
Right. So again, I think I'll work backwards from that question. Getting momentum is always about showing results. How do we start small and show results immediately and build from there? Right. That is nobody can argue with results, and that tends to be the best place to start. In terms of costing it out, so please go to that other webinar, that will actually be discussed on the build versus buy in kind of a lot more detail around that works. But you have to think about, so the high level cost that you think about is getting the first thing, right, running. Okay, so how do I get the first level of operations? Who's going to be the engineers working on that? Who are going to be the DevOps engineers maintaining it? And that's kind of like the first step of understanding kind of what the cost is. And then every single time you add another model development technology or an integration point, there's now an extra testing, extra build out, extra kind of like, expansion on that. Obviously, so every single time you add a feature, it's going to be more expensive. The real cost comes at upgrade times. So when you start thinking about like, okay, we got our main ML operations kind of thing up and running, what happens when I now need to go upgrade all these components? So do I need to actually go every single component, every new library, every new TensorFlow framework, PyTorch framework, database, containers, like orchestration layer, every single one of those components is going to have an upgrade cycle. And so thinking about what the cost is going to be to run upgrades to every single one of those things with zero downtime and building out is where the real big cost function is going to happen. So think about maintainability, and future proofing is really where the big costs are going to be. But from a personnel perspective, I think bringing in the users are really going to be who's consuming this. So what are the conditions that the application developers need to do to be able to consume this comfortably? The DevOps IT team that is likely going to maintain the runtime for this. And then are you actually providing the speed and iteration and ease of use to the data scientists? So those are the three personas that we like building, bringing to the table. Obviously you want management, you want a sponsor, because that's how you're going to get anything done. And the sponsor is going to care about ROI, right? So as long as you nail that ROI and say, hey, if we can get this quickly, we're going to see ROI. The three personas are that data scientist, kind of like DevOps ML engineer, and the application owner.
Nice. That was awesome. Here's an interesting question. So the person asks, in cases of image, speech, text, or video, how do you consider KPIs? And I think to broaden that slightly, yeah, so with just different models for different applications, does the KPI measurement change, and do you need a different infrastructure of KPI infrastructure in place for totally different model types?
So the answer is yes and no. So and I'll talk a little bit about that. So some KPIs are going to be the same, right? Because it doesn't really matter what the models are. If you're thinking about, hey, I need it, like this application that's calling model blah has an SLA of X. And I'll give you a good example of this, which is on your website, you have, less than 7 seconds to show something before somebody loses attention. So that SLA, no matter what you're doing on your website, is strict, right? In most cases, it's under 100 milliseconds is what people will request. And so as your models are getting into production, being able to provide the inference and the predictions inside that SLA, it doesn't really matter what your model looks like. You can obviously think of things like accuracy and kind of like how the model's behaving, and those do change by model and model type. And then, but the KPIs around compute are going to be like, you could say, hey, we can't make this infrastructure more efficient. Like this is what it costs to do this kind of thing. And those translate. So the answer is like, there's a lot of the ones that, especially the ones that I just talked about, generalized in terms of how do you track those, but you're going to have individual KPIs for certain, I wouldn't say per model, but per certain workflow, right? Because models don't live in isolation. It's about that workflow and the KPIs around that workflow. Because again, you're affecting an ROI on something. That's the only measurement that really matters. Now, that measurement is a compounded effect of a whole bunch of different KPIs along the way.
Nice. Awesome. That's helpful. And then here somebody asks, what bug tracking program management tools do you prefer? And I think to broaden that slightly, so bug tracking, and then just if you can add some nuance to just model maintenance in general, that would be interesting.
Yeah, so we've taken an approach of there's a lot of really good tools that already exist. So we've taken this combination of a Git approach, so using any source code management that is based on Git that has really, really advanced tooling. So pick your favorite source code manager, and this idea of kind of like applying through GitOps, but also the tooling around and tracking around bugs in that code, combined with some sort of versioning on object storage for model files. So the combo of those two is kind of how we've tracked versioning and around the platform, and then trying to look, we don't need to reinvent the wheel for bug tracking. So obviously there's certain parts in model building like experiment tracking, which are really important. I don't know if I'd call those bugs, but having a good solid experiment tracking framework in place is going to be hugely important for success of the model development. Once models are in production, we believe you can use a lot of the tooling that is already existent for kind of like DevOps in terms of bug tracking and things around. One thing that you can actually do around the collaboration, we have this in our platform, but it's also, if you think about it, is how do people report back where new use cases are used and they don't work? And so we kind of track that as part of that Git repo that we take the entire production model. So all the documentation lives in that Git repo. Pointers back to your training and experimentation systems lives in that Git repo. And then any sort of reported bug as well as unit tests will be tracked inside that Git repo. So that's our approach on the design. I think there's other ways of thinking about it, but I would try to really think about, is there anything different in bug tracking in ML outside of, hey, we need to have pointers on what the data was at that time and freeze that. And, so you have the data changing component, but like, do I really need something completely different here? And that's a question you'd have to answer for your particular use cases.
Cool. Nice. Thank you. Here's one on model reusability. And the question broadly is, could the developed model itself be reusable, and to which level? And then I'll add, if you could touch on, transfer learning is becoming more and more viable, and how does model reusability, transfer learning fit into your ML platform?
Sure. So transfer learning, I would argue, is more on the training and development side, because you're starting from a base of something that already exists and kind of expanding on it. And so I think it's an amazing technology that is creating incredible efficiencies in terms of use cases. I consider the reusability that I talked about today slightly different, in the sense of, hey, if I've already built, here's a good example of it. So for those of you in financial services, you're probably familiar with Edgar. So Edgar posts like all the S1s and all that type of information. So like every single bank that I've ever talked to has built like 14 Edgar extractors, right? There's a model where you can like grab those documents, extract it, structure that data, put it somewhere else, and then reuse that as inputs into a different pipeline. So that's a really good example of a model that can be reused by private wealth management, by your equities desk, by your, and so this is good examples of reusability internal to the organization around that. And then you have kind of like more generic models, like, hey, if you have a car make and model, thing, and that model can be reused for a parking lot, for counting kind of like, what's going in and out of that parking lot from CCTV thing. So it really depends on the use case. I think transfer learning really is around kind of creating slightly newer use cases based on a base layer of data, a trained model already. When we think about reusability, it's legitimately like, hey, this works for that data source, so I can use that multiple times in my organization because we're using a lot of the same data sources for different use cases.
Cool. Got it. Noted on reusability v transfer learning.
It's a good question.
A couple people are asking around this like self-service idea. One person's asking, right, if I'm a non-data person, what's a good self-service BI tool? One person's asking, what's the scope of a self-service approach? And I guess if you could touch on the concept of, if you have like this robust ML pipeline and platform and totally operationalized, who can be the users of it? And to what extent, is self-service actually viable, and for whom?
Yeah, so I think when I talk about self-service in this particular use case, it's really about creating a high-speed highway for the data science team into affecting the applications that they need to affect, right? I think this is from a self-service, this is really about the challenge that we've focused on is that there's a giant gap between I'm a data scientist with a model and I can run this now in my application in production. And increasing that speed and that kind of highway has really been the focus. And that's when we talk about self-service. What we mean by self-service is if I'm a data scientist and I have a model and I push it into the system, it's an IT approved security standard, governance standard, auditability standard. Like there's no red flags or red tape around getting this model in production, assuming, you have like the right compliance and stuff like that. So when we talk about self-service, is really about that. If you want to take one step behind that, which is, hey, can we get to a self-service model building experience. There's a whole bunch of tools in the auto ML space that are really fascinating and are really good. And that's kind of where around the model building self-service comes. And I don't really have an opinion on which tool to use. There's a lot of auto ML tools out there. You can experiment with them yourself. But those are the ones that would provide kind of the like self-service creation of models. What we mean about self-service is really, I have a team of data scientists and they want to get into production as quickly as possible. And we provide a highway for them.
Cool. Got it. Thank you. Here's a question. Curious what this means to you. Do these, KPIs have any SLA to attach with them, or does this depend totally on the use case being implemented?
I think it really will depend on the use case being implemented. If you think about, different, a batch process that runs every night is very different SLA from some, real-time video analytics application, right? And so while for each one of these we can attach, SLAs are going to be super important for delivering the experience of the target application. And those vary, right? Use case to use case. It's very different. You have a different expectation from, a recommender on a website than you do over something that, kind of gets calculated once a night around that. And a good example of this is the Amazon recommender, that calculates overnight, right? So like all those like, hey, if you bought this, bought that thing, like that gets calculated once, a day, essentially overnight, this massive process. And so where's the SLA there? Well, they just need to be able to, like the recommendations need to be able to provide really quickly, but the recalculation of that model only needs to happen once a day. They might be faster now. But that's kind of, so it really is tied to the use case in terms of, what is the performance, which goes down to like I said, what I said at the beginning, like, what are we trying to solve for here, right? Like machine learning is an optimization on a process and it's allowing us to do something. What are we trying to solve for? And what are the business needs for that? That's what's really going to determine the SLA.
Cool. Got it. Thank you. Talk a little bit about model redundancy and backwards compatibility. How should we think about that in terms of our ML?
Yeah. So if you're going to be thinking about kind of like enterprise level model deployment and usability, one of the things that's really important is to start thinking about what are the refresh cycles of the consuming applications. So if I am a mobile app and I'm calling a model, but then I have a web app in the same company calling that same model, is it okay that the model might change without, versions, without that team knowing about it or participating in the testing or kind of verification process? And so what you want to start thinking about is, hey, can I actually run multiple versions of this model at the same time in parallel? What that allows you to do is actually say, hey, if your sprints, for example, in terms of in terms of application refresh are different from different teams in an organization, can we not be affected by changes to this model unless we really want to? So what we've done is we think about kind of this API versioning as well as model versioning to be really tied together, but also this principle of every single model should always be called every version, unless obviously it's a bad model and you want to kill it. But like we have this general concept that you can actually run every single version of a model in production at the same time. And that goes back to that audit and understanding, hey, who's still calling this old model? Can I go to them and say, hey, you shouldn't be calling this? So that's where the tracking becomes really, really important and being able to show who's calling stuff. But at the same time, we do live off of this principle that there's going to be different refresh cycles, not of the model, but of the actual consuming applications. And they are going to have a say in terms of, hey, we can't verify this right now. I know that you're telling us that it's the best model and it's new, but we've actually not verified all our use cases. And so being able to think about kind of global consumption and versioning is kind of how we've actually framed that.
Cool. Awesome. That's super helpful. All right. So we're just about at time. So I'm going to ask you one more kind of zoomed out question to end. So 5 years ago, where were we in the, MLOps and enterprise setting? Where are we today, 2020? What's the difference? And then where will we be 2025 in terms of the state of, MLOps in the enterprise?
That's a great question. So I think my co-founder is one that I think placed this in the best way. So if we think about a spectrum of maturity, right, in computation, right, we started with punch cards and we've been adding abstraction layers, right? So punch cards to like Unix systems, to DOS systems, to Windows systems, to Mac. And today, we're in this concept of app stores, right? Like it's the most abstracted thing possible, an app that just runs on different targets of things. And so if we actually think about where machine learning is from an abstraction layer on that spectrum, we're probably closer to Unix system like abstraction than we are to model, to the deployment factor. So obviously we've seen a massive amount of maturity in tooling that's come out in the last couple of years. And so I think the growth and the maturity of this cycle, again, we get to look at things that have worked already, right? While, in the traditional software abstraction layer, it's been, it was all new. Now we get to like say, hey, well, this worked for DevOps and this worked for this and this worked for analytics, and how much of that is applicable to this world. So I think the maturity and abstraction rate is going to move a lot quicker, but we are closer to the beginning than we are to where we are on the other side.
Got it. Thanks. So you heard it here first, folks. The age of ML that we're currently in is the punch card age. All right. So Diego, massive thanks. You crushed it. Thanks for bearing with us with all these questions. And to everyone asking questions, the recording and slides will be made available after. And I'm sure Algorithmia will be able to send around a link to the other webinar that's on the screen right now. And yeah, if you have any questions, we'll figure out how to get you in touch with Algorithmia. You can always hit up AI4 and we can connect you. So I wish you all a healthy and safe rest of your pandemic. And Diego, yeah, thanks again for being here.
Thank you, everybody, for listening. Really, really enjoyed it.
Have a good week, everybody. Bye.